Okay, hello and welcome. This will be the third and final video of the lab menu series or whatever. And basically what I'm doing here is I'm trying to explain the labs in this portion of the lab menu. Now, these are the hardest labs offered, basically, except for the last one, in which case it's variable. But this is really where it gets kind of into the data, basically. And for a lot of these, you're going to have to maybe write a little bit of code. And, for the master students, I pretty much require you to do at least one of these. For undergrads, I strongly encourage you to do it, especially if you're scared of it. That's exactly why you should dive headfirst into this stuff. But I'll kind of give you the option of what to do. And honestly, you don't have to do any of these. You could just totally avoid this completely. And I understand that too. That would have been me as an undergrad. So let's just go from the top here. So query the US Census using the API, right? The API is the application program interface. And this is a way to get at US Census data. Basically, at the very end of March 2021, the 2020 census data will become public. Now, the census, if you filled it out, and I hope you did, it covers a lot of stuff, right? There's a lot of questions on it. And then all that gets tabulated into like all these different metrics about people in different geographies and where they live. There's too much stuff to put in one table, basically. And so what you have to do is you have to query this API. And you have to say, okay, I want to look at census tracts, or I want to look at census blocks, or I want to look at zip codes, or I want to look at states, or I want to look at counties, or census designated places, or whatever. There's all these different geographies that are associated with the census and how they collect data. And then they aggregate all the statistics into those geographies. And then you can say okay, I want to know how many men, how many women, how many total people, Black, brown, Asian, whatever, all the demographics, what's the median household income, et cetera, et cetera, et cetera. And there are I think there's literally hundreds of these variables that you can get for every one of these geographies, basically. So the point is that you can't really just get it all because it's too much information. So what you have to do is you have to query the census API, and you have to get this key. Basically, they give you a key code, and it's a little bit tough. And you basically have to create this notebook in Python, and you have to call the website, and then you put in your key, and then you say, here are the geographies I want, and here are the statistics that I want, and then it spits you out some outputs, and you take those things, you put them together, you put them in GIS. The good news is that this has sort of been done for you a little bit already. So we had a computer science student, his name is Viet. He taught the president of the GIS club, Ethan McGee, how to do this. Basically, he just wrote all the code to do it. He wrote a little Jupyter notebook, and then he made a video. So I just had them record a video of Viet teaching Ethan how to do it, and they just walk through the process, right? And then Ethan told Grace, who is the co-president of the GIS club, basically how to take all these outputs and put them into GIS. And so there's a second video where Grace and Ethan kind of go through the process of getting all these things in tables, attached to the geographies, and then actually brought into ArcGIS Pro to actually do some analysis with it. So if your project involves anything with people and where they are and what types of people are there, and a lot of your projects will, this is a really good skill to have. And you'll learn a little bit of Python, but you don't have to write a lot of it because a lot of it's already there. You might have to go in and change something here or there, but there's already some videos for you to get kind of started on it and that kind of thing. Plus you're using brand new data. The data is not out at the time that I'm recording this video. It comes out a week after I record this video. So it's exciting. It's the first time that people are getting their eyes on this stuff. So that's kind of neat. Geospatial analysis and statistics in R. If you're not familiar with R, R is a programming language. Google R. And it's this project for statistical computing. So statisticians love R because it's free, it's open source, and there's a ton of statisticians who have written statistical libraries to do really advanced statistics in R. It's a little tricky to deal with, frankly, and you have to be comfortable with the command line, and you have to be kind of comfortable writing a little bit of code. The cool thing about R, though, is that it can actually deal with GIS data. So it can do a lot of these things. It can call these spatial libraries, which are the same libraries that you're calling from ArcGIS, and it can do a lot of this stuff in an open source environment. If you're considering going to graduate school and you're considering a slightly more technical field and you like statistics, you should get to know R, because it is a really handy tool, basically. And like I said, statisticians use it, grad students you love it, a lot of academics use it, and a lot of people in industry use it too for data science. So it's really handy, basically. I use it a ton in my PhD work. I like Python better, frankly, but R has some tools that Python doesn't have. So you basically use this statistical programming language to go and analyze geospatial data. You can pull in shapefiles and that kind of thing. So these are these tutorials, basically. Oh, I need to update that link. But basically there are these links, and you'll have to download R. There's actually a bolt-on on top of R called R Studio that's like, I don't want to use the word sexier, but it's a little bit flashier, I guess. It kind of looks a little bit nicer. And you can still access R and all these things. So you got to be a little nerdy to tackle this one. And you have to be like, ooh, I want to go to grad school. Like, I like stats. Like, I'm not afraid of like punching things in the command line. If you're not afraid of that, go for it. This is a great one to learn. Okay, Google Earth Engine tutorial. So yeah, so long story short, you've been on Google Earth, right? Everyone's been on Google Earth. I can even bring it up, maybe. And what Google Earth did was they basically aggregated all of this satellite imagery and aerial imagery into one platform, right? And Google Earth and Google Earth Pro basically are just this, graphical user interface kind of tool that's like kind of button clicky, and you got all these like cool tools and stuff like that, where you can zoom around and you can look up your house and whatever, turn back the clock and set tours and put in all this stuff. Google Earth Engine is like what's behind this, basically. Now, be aware that some of the imagery in Google Earth is high resolution. They've bought it or they've sourced it, and it costs money, and you can't quite get to it for like an analysis. But for all of the free data, and there's a ton of free data, Google Earth Engine is the best aggregator of information. Okay, so like one example is you look at the map and there's no clouds, right? But like there's clouds everywhere around the globe all the time. So to take out the clouds, you have to train a computer to identify what a cloud is and then take it out, basically. So they've done that, right? And so like the Amazon is cloud free. Isn't that nice, right? And when you get down into like the Amazon or like some of these remote places, you'll notice that like sometimes the imagery gets a little bit coarse. And in this case, not so much, but you go to certain areas where it gets kind of blurry, right? And what this is a bunch of different images on top of each other of these same areas, and like depending on what zoom level you're at, or what time you want to look at, Google says here's the best image for you, and it just subs it in there, and it just does it kind of seamlessly, right? But you can actually do this programmatically using either JavaScript or Python. So you can say, okay, just look up Google Earth Engine. But basically, Google Earth Engine is this kind of dynamic environment where you can actually go in and say, I want to look at this area. And so this is the JavaScript environment, it's the code editor, basically. And so you basically will say, like, I want to look at Landsat imagery for this area. And I want to look at it, I want to find the NDVI, the greenness index. And I want to look at it for every single month for the last 20 years, okay? Now, if you wanted to do that in like a local environment, like you would in Geography 328 or like a remote sensing class, it's a pain in the ass. Like you have to download that data. Each one is a gigabyte. It fills up your flash drive, right? They're big, they're bulky, they're slow, all these things. What's cool about Google Earth Engine is that it does all of that for you in the cloud. So they have stored 45 petabytes of data, right? Of like all of the publicly available satellite data, pretty much from the beginning of when satellite data has been collected, also aerial imagery from some sources, and you can actually put in your own images. So if you found your own images that weren't in there, you can actually put your own images up in there. There's also a Python API. So like you need to know a little bit about some basic coding. The cool thing is there's a lot of libraries, there's a lot of stuff that's already been written for these platforms. Amazon's trying to copy this right now, actually, but it's a really neat kind of platform. I think it's extremely powerful, and I actually think that this is kind of how how remote sensing is going to be taught kind of in the next generation. Just like watch this little video here. Hopefully you get the sound. I don't know if you will or not, but it doesn't really matter if you do or not. But they started taking in Sentinel, which is the European Space Agency kind of constellation of satellites, which has microwave imagery, it has thermal imagery, it's got Landsat since like the early 70s, I believe. It's got NAPE imagery, which is 1 meter, 4-band, multispectral across the entire United States, as well as a bunch of other kind of data sources. And what's cool is that they hold it all for you. So you don't have to download a single image. You go in there, you go into the APIs, you plug in a little bit of code, you call these libraries, and then you pull in stuff. You can do your analysis. It's all there. So you can do it on a little like MacBook Air, Chromebook, whatever. It doesn't like, you don't need any computational muscle, basically, right? You can pull in elevation data, you can pull in climate data, you can pull in topography data, you can pull in, you know, your vector data from GIS, that kind of thing. And then you can export them. So you can export them out as files that you can read in your GIS, which is really cool. Like I said, you need to know a little bit of Python or a little bit of JavaScript. So like, if you're going to dive into this, you need to learn a little bit first. But you can see like the power of the time lapses here, right? Like this is coal mining or urban expansion or whatever, and you can do these really interesting time lapses and that kind of thing. And some of these things I've already highlighted. The global forest change, tracking deforestation around the world, it's all done in these cloud environments. Basically, you have to do it on a supercomputer. You cannot do it on a local computer, essentially. So that's kind of what's exciting about it. And this platform has made it basically accessible to the average person and now students as well. So there's a ton here. You could spend all quarter in Google Earth Engine if you wanted to, and I encourage those of you who are into remote sensing to consider maybe doing that. Okay, SQL and PostGIS tutorials. So if you're into big data and you have big data sets, it's good to put it into a big geodatabase, a spatial database, basically. And the way you query those databases is using SQL and something called PostgreSQL. Which is the spatial version of SQL, basically. It was developed at Cal, Berkeley, like 10, 20 years ago, something like that. And then it was just turned into PostGIS. It's all open source. It's all free. So you can actually do all this. And there's a couple tutorials that will sort of teach you how to do that. Okay, if you really like ArcGIS and you're into Python a little bit, you're a little code curious, there's the ArcGIS Python API tutorials. There's a whole series, basically. It's like 13 hours of like all these different tutorials on how to basically help you do all of this in the cloud. There are something called Jupyter Notebooks, and Jupyter Notebooks, it's Jupyter, P-Y-T-E-R, and it's specifically geared for looking at Python code, but ArcGIS has integrated these notebooks into its platform, and you can use them in ArcGIS Pro, and you can actually use this API with these notebooks. Actually, one of the creators of Jupyter Notebooks is actually at Cal Poly. He's a physics professor, which is kind of cool. It was, I think, actually a couple professors at Cal and a couple and this guy at Cal Poly kind of created these Jupyter Notebooks, and now they've become like, everyone who does data science now uses these Jupyter Notebooks, and they're great. And you can do all this like cool GIS stuff in them now too, which is really kind of fun. So you can actually, and what's neat about it is that you can like write like a line of code, and then you can hit go, and then like you'll see it like heads up on the map, and so like you'll get like these cool visualizations so that you can like see things as you do them, and it's really gratifying to like, oh, it's like immediate kind of response there, which is fun. So I made this worth 150 points if you go through the whole series, basically. And so you go into Canvas, go into the lab, look at the introductory thing. There's like a half-an-hour introductory thing that would tell you like, maybe this is for me, maybe it's not. But if you want to go through the whole thing, that could be half your lab grade, basically. What's cool about that is you can apply it to like so much stuff. So I encourage people who are code curious and not afraid of a little bit of Python. Also, if you do that Python for Everyone course first, that kind of thing, like kind of have to build these things up. So the advanced ones are, towards the end of the quarter, or if you're already there, great, go for it. But oftentimes you want to like build those base skills before you get there. Okay. Finally, make a public GIS video tutorial, right? So chances are you've gone online and you've looked up some tutorial video, and somebody made a tutorial video. Who knows who they were, right? It's a good chance it was like some Indian guy. Like there's so many GIS videos that were made by like these Indian men, and they're awesome. Like they do such a good job. And it's like tech support, like for the internet. Like these guys have just like, guys and gals, but there's a lot of people who've like put a lot of time, and they're not all from India. Certainly I've made some of these. They're everywhere, right? And they're super helpful. Professors do it all the time, especially with online learning. It's like, I kind of feel like I'm constantly making videos now on how to do these things. But the point is that like, it's a community, right? And you don't want to just take from the community, right? So like you can just watch the videos and do it, and like maybe you don't even give them like a like, even if you use it, which is like you being a total dick. Like if you're using it and you like it, give it a like, right? Be nice. But the point of this is like make your own, contribute to the community as opposed to just taking from it, and give back a little bit, right? So if you have something, and again, this is maybe something for later in the quarter where like you're having trouble, I don't know, querying the census API or joining a table or running this tool, or you're getting an error message or whatever it is, you're having something that is a problem and you don't quite know how to fix it, right? And then you finally figure out how to fix it, and that will of course happen to you. You'll best your problems. Once you do that, go back through the process and explain it. Like do a video, screen share, and then just go back through it and go through the process of explaining it. Make a video of it. You can do it in Zoom, just like I'm doing now. You just record your screen, upload it to YouTube, make it public, give it some good like descriptions, like this is me querying the census API, joining these two tables using this like weird thing that I had to reformat in the description. Like you can always put like, comments, or like, here's a little code that I used, or like, here's a little bit of, some resources or whatever that I used, and this is how I did it, and then put it up on the internet, put it up on YouTube, and just make it public, and maybe people will use it, maybe they won't. I made some crappy video like when I was looking for jobs like 5-6 years ago, and it has like 6,000 hits, and it's not even a very good video. But the point is there's people out there, they're looking for answers, and they need these resources. So like you can provide some answers, and also like maybe you've got a friend in the class even who's like trying to do something. It's so much easier than sitting on a Zoom call, like, and trying to like walk them through it. Oftentimes just do it yourself and explain it and record the video and just hand it to them, right? It's easier for them and it's easier for you. You don't have to schedule it, right? So in some ways that's kind of nice. So this lab here is a variable credit lab, 20 to 40 points, depending on how hard it is, basically. You don't want to create something so easy, like here's a tool that I ran, here's a video of it. No one cares. That's like easy. If there's no problem, then like what are you helping with? Also, if it's too complicated and too esoteric, people aren't going to look at it either because it's too nichey. It's like it's too in the weeds, and people are just like, I'm not too sure what they're doing there. So it has to be somewhere in the middle, right? It can't be too easy and it can't be too hard, can't be too short, and it can't be too long. So like talk to me before you make one of these videos, and like let's just talk about like, okay, let's it should be a 5-minute video and you do this, that, and the other thing, and that kind of thing. So let's just have a conversation before you go there. That's kind of what I'm saying. Okay. Speaking of having conversations, the very final lab here is this wildcard lab, meaning that you pick it, right? So you go on to Esri Academy. And there's all this e-learning stuff there. And if you only have a Mac and you want to deal with ArcGIS Pro, do the online stuff. ArcGIS Online's got a bunch of stuff, basically. But you have this catalog here. You can go to the course catalog. And you just start looking for stuff that you want, right? And what I normally do is click free, always click free, but also sign in, make sure that you're signed in. And then like there's all this stuff. So like, okay, I want to learn about scripting. I want to learn about like field stuff. I want to learn about remote sensing. I'm just getting started. Like, I'm not really sure, right? And so like, oh, I'm trying to do analytics, whatever it is. So you can filter these things based on whatever it is you want. And like, there are so many things that you can look at. So this is cool because you can pick your own thing. And then basically I just give you credit for it based on how much time you spend on it or how much time you're supposed to spend on it. So like this one right here, explore and animate geological data with voxels, right? Voxels are volumetric pixels, 3-dimensional pixels, which are good for looking at rocks, apparently. It takes about an hour. Complete this tutorial, you'll get a little certificate at the end. You upload the certificate, and you say, okay, it took me an hour, or it's supposed to take you an hour. It might take you longer or shorter, but then you get like 10 points for that, right? And the more you go into this stuff, right, there's these longer ones, right, where it's like, okay, there's actually like 5 courses, or there's like a series or whatever, and they could take weeks, right? So just get in here, start playing around with stuff, and just start searching. So just start searching in here for like search terms that you think are cool. So like, I don't know, drones or whatever, right? So you get the idea. You know how to search stuff on the internet. But go to Esri Academy, go to the catalog, search stuff out, and that's this wildcard. So it can be worth your entire lab grade. You could just spend all your time in Esri Academy and do 30 hours of labs approximately, upload all of that proof. There you go. You don't have to touch any of the other labs. You can just focus solely on what you want to do. what I'm saying about the labs is that actually they should be like easy money in terms of points, right? Because I'm really not grading for like how well you're completing things. I'm really just grading on like completing them. So get them done, prove that you got them done. A good way to do that is to like, have a running document and just describe what you're doing and insert screenshots. This is what I did. This is what it looks like. This is what I did. This is what it looks like. You get to the end of it, especially with these Esri things, they have a certificate of completion. They email it to you. Here's my certificate of completion. Boom, you upload that, you get credit, right? So as long as you are willing to put in the time, you should be able to do these things. And so that's kind of the long and the short of the lab menu. Basically, it's a little bit bold on my part in terms of like trusting you to do whatever it is that you want to do. What I will say is that by about mid-quarter, and I'll specify this in the syllabus, you have to have like a third of your labs turned in so that I can start grading them, basically, because I can't be saddled with grading all of this at the very end. I need to have some time. So like, I think it's gonna be around week 4 or 5. Like, you got to have like 100 points of the 300 points turned in to grade, basically. So that's all I'll say for now. Just reach out on Slack if you want any sort of additional kind of clarification. But this is the pick your own adventure here. If you want to go QGIS and pick all these tutorials, great. Also, like just wildcards generally, just pitch it to me. Just say like, hey, I want to do this thing. I found this thing that you didn't list. This is this totally different thing that I heard about. There's a lot of stuff that in here that in the GIS world that I haven't listed, and I'll talk about in my lectures and that kind of thing. But there's a ton out there. So if you find something it interests you, you want to spend some time on, you want to get good at it, you want to build some skills, great, go for it. Just run it by me first, and then we'll be good to go. So with that, I'll sort of stop this video. That is the lab menu. Hopefully you take advantage of it. It kind of goes without saying, don't do stuff that you already know. Right. So like, oh, I already like created like a story map. I already have like an online web map. I'm just gonna like put that up. It's like, don't do that. Right. And like, even if I can't tell, just pick new stuff. The whole point here is to learn new stuff. So hopefully you can dive into it and take advantage of the fact that I'm giving you freedom. I'm not making you do pre-prescribed labs. You do whatever it is that you want to do in support of your goals. So hopefully this is helpful, and hopefully you appreciate the freedom that you're allowed here. So.